Thanks for joining us for the interview portion of the Data Speaks competition, created in partnership with RFG 2018 and Sequent. I'm Nicole Doucette, a science communication specialist with Sequent, and I'm joined today by Rebecca from Memorial University of Newfoundland. Welcome.
Hi, thanks.
Okay, Rebecca, your original abstract title was Role of Crustal Contamination, Melt Immiscibility, and Hydrothermal Processes in the Formation of Magnetite-Apatite Deposits, Atacama Desert, Northern Chile. So what is your revised non-specialist abstract title?
So my revised title is Hungry for Iron, Bring Your Apatite.
Yes, and I would like to point out that apatite is spelled like the mineral, so it is a geology pun. So what question are you trying to answer?
Yeah, so very simply, we're basically answering how do these deposits form. So in 1975, there was a large deposit, iron deposit discovered in Australia that contained copper, gold, uranium, a couple other things. And that kind of jump-started all this research and fascination with a deposit type called iron oxide copper gold deposits, or IOCGs. So the problem now is that a lot of these other deposits started getting lumped into this classification. And a prime example of that is magnetite-apatite deposits. So magnetite-apatite deposits, they're exactly that. They're magnetite and apatite. So they have the iron oxide component, but apatite is a phosphate, and there's no copper and there's no gold in there. So they have kind of been deemed the copper and gold poor end member of IOCG deposits, but we kind of want to separate ourselves from that, and we think that magnetite-apatite deposits should be their own specific classification.
Okay. Great. So what concept does someone need to know to understand your research?
I guess you first have to understand that we're able to use one mineral to kind of answer this question, and that mineral is apatite. So we're able to do that because apatite is such an important geologic mineral. I kind of like to think of it as a garbage can mineral. It really incorporates like all of these, like half the periodic table into its structure.
Wow.
So you can, so the simple laws of chemistry just govern that like elements substitute for like elements, and they all just get stuffed in there. So it takes a lot of elements that other minerals can't. So if you have an apatite that forms in a magma, you're basically able to analyze it, see what's in it, and you can have a pretty good idea of what types of elements and conditions that magma was under. Likewise, if the apatite was formed in a fluid, then you can analyze the apatite, see what's in it, and you can get a pretty good idea of what's in the fluid. So we're able to use apatite to answer all these questions about magnetite-apatite deposit formation. And because apatite is so ubiquitous throughout a bunch of rocks, we can have it in the host rock and we have it in the ore. So we're able to directly compare both types of rocks in the system.
Great. And so what role does data play in your research?
There's a few different data stages, I guess you can think of it. The first one was data collection. So we actually went to the Atacama Desert in Chile to collect our samples, which was a great trip. I highly recommend it. It was like the surface of Mars, honestly.
Oh, wow.
Like, it was really cool. But anyways, you have to make sure you're picking samples that are representative of the population, right? So that takes a degree of preparedness and observation. And then we have data processing, which is I have to get from a fist-sized chunk of rock down to little grains of apatite. So it's not a glamorous stage, but it's pretty necessary. Mm-hmm. And then the last one is data collection. And we use a bunch of different techniques and instruments to analyze our apatites. And I don't think the names of those are really important, but what is important is that we collect really good quality data. So this is apatite geochemistry. It's quantitative, so you need really precise numbers. And you can't get those wrong. So I like to think of it as your interpretations and ideas can change over time, and they will when other scientists come along and look at your stuff. But your data has to be true and has to remain true through time. So.
Definitely. And so why is it important for you to share your data and your research?
I think it's important because there's no denying that the human population will continue to grow over time, and with that, our amount of materials that we need is going to increase. Mm-hmm. And iron, which is the main commodity in magnetite-apatite deposits, is going to remain a large part of the economy because we need it to produce steel. So as these cities, grow and modernize, the demand for steel will go up. So that's one big part of it. So if we can understand how these deposits form, then we can understand how to find them. And that's also going to be much more important because all the easy to find, obvious deposits have pretty much already been found. So we need to help people be able to find the ones that aren't so obvious anymore. And additionally, not only is stuff like steel going to be more important, a lot of our stuff's getting a little more complicated. So things like rare earth elements are brought into play here. So take your smartphone, for example. Like cell phones didn't exist not too long ago, but they rapidly evolved into this like little mini computer in our pockets, right? So there's about 16 rare earth elements in your in your smartphone. So not only is there going to be more people who need more stuff, the stuff gets more complicated as we move along, right? So during our research, we actually found out that a lot of these deposits have economic concentrations of rare earth elements. So that kind of allows us to say, you know, past producing deposits and even currently producing deposits, you might want to reevaluate your resources, and you might be able to economically start pulling out these rare earth elements. And then likewise, you know, when people find deposits in the future, you should be thinking about rare earth elements right from the start.
Okay, great.
Yeah.
Thanks
Thank
for
you.
joining us today, Rebecca.
Thanks.
Once again, this is the Data Speaks competition at RFG 2018, created in partnership with Sequent. You can watch the videos on YouTube or Twitter, #CDataSpeak.